All right, let's see. Today we're going to talk more about quadratic functions. More about quadratic functions. All right, and yesterday we talked about vertex form of a quadratic. And the vertex form of a quadratic function is when we get an f of x equal to a times x minus h squared plus k. Now, I want to go through this information one more time. Yesterday, we talked mostly about the vertex. All right. We said that the vertex is located at HK. All right. So the x value at the vertex is the opposite of whatever's next to the x in the parentheses. The y value of the vertex is the value that's to the right of the parentheses. We said that the axis of symmetry was x equals whatever this h is. So whatever the y value of the vertex, or I'm sorry, whatever the x value of the vertex is, the axis of symmetry is a line x equals that value. Okay? Now, the next thing we're going to talk about is a minimum or maximum. Then we're going to talk about the domain and then the range. All right, and all of that information comes from the equation when it's in vertex form. So now, this a value right here. Remember yesterday we said if positive, graph goes up. If negative, graph goes down. All right? So if this a value in vertex form, whatever's between the equal sign and the left parenthesis, if that value is positive, then the graph goes up, meaning it looks like this. Graph goes up. It looks like this. It's a parabola that goes up. If that a value is negative, then the graph of this function, which is a parabola, it goes down. Now, you're going to be asked some questions today and tomorrow and Thursday, and it's going to be worded, identify the vertex, the axis of symmetry, the minimum or maximum value. All right. When a vertex or when a graph of a parabola goes up, its vertex is at the bottom. Okay? When a parabola or the graph of a quadratic goes up, the vertex is at the bottom. And that graph has a minimum value. Okay? when the graph goes up, let's write this down. When A is positive, the function has a minimum value. When A is positive, the function has a minimum value. That's because the graph goes up and the vertex is at the bottom of the parabola. When A is negative, the function has a maximum value. And that's because when your A is negative, the graph goes down and the vertex is at the top. When the vertex is at the top of the graph, it has a maximum value. When the vertex is at the bottom of the graph, then the function has a minimum value. So when you're asked if the function, or to describe or to identify the minimum or maximum, if the graph goes up, it's got a minimum value. If the graph goes down, it's got a maximum. That's it. Good with that? All right. Now, the domain of the function. We said a couple weeks ago that the domain, that's your input. It's also known as your x values. If the parabola goes up or down, those are the only functions we're working with right now. The parabola either goes up or it goes down. If the parabola goes up or down, the domain is all real numbers. If the parabola goes up or down, the domain is all real numbers. That means you can put in all real numbers for x. Your input can be any and all real numbers. Later, we'll work on, no, I'm not even going to say anything right now. If the parabola goes up or down, so all the graphs that you're working with right now, if you're asked to identify the domain, what would the domain be for all the graphs we're working with right now, or all the functions we're working with right now? Good, it would be all real numbers. Okay? Now, the range. When you're asked to identify the vertex, axis of symmetry, maximum or minimum value, the domain and the range of the function is determined by the y value at the vertex and the value of A, and the positive or negative of A. I'm going to show you how that works here in just a second. The range of the function is determined by the y value at the vertex and the positive negative of A. So for this function, let's say that the function of x is equal to 2 times x minus 1 squared plus 4. If we had to identify the vertex of this function would be located at 1, 4. The opposite of what's to the right of your x is your x value at the vertex. Whatever's to the right of the parentheses is the y value of the vertex. The axis of symmetry for this graph would be x equals 1. Does this graph have a minimum or a maximum value? Minimum or maximum value? Does the graph go up or down? If the graph goes up, does it got a minimum or maximum value? It's got a minimum value.
It's got a minimum.
It's got a minimum value. Good. The domain of this function, that's all real numbers. You can abbreviate it, ARN, all real numbers. You can put in anything you want for x, and you're going to get a y value. Now, here's how this range works. The range of values for this function, the f of x's, the y's, okay? If we were to graph this function, it would look something like this. It's going to go up. It's going to have a vertex. This point is going to be at 1, 4 on the coordinate plane. All right. It's going to have an axis of symmetry that goes right through the middle of it. The equation for that axis of symmetry is x equals 1. Now, this is sitting on a coordinate plane at 1, 4. And everything is going up. Agreed? The parabola has a minimum value. Its minimum value is down here at the bottom, at the vertex. So the range of values for this function, all of the y's, you're going to write this as your y's are going to be greater than or equal to 4. All of the y values in this function will be greater than or equal to 4. All right? Set up here that the range determined by the y value at the vertex and the positive or negative of A. So when this vertex is at a minimum, then our range is going to be greater than or equal to the y value at the vertex. All right? When the function has a minimum, your range will be y greater than or equal to the y value at the vertex. That number will be the same as this number. If the graph goes up, this will be greater than or equal to. Okay? Now we're going to take a look at one that goes down. So let's take f of x, our function of x, is equal to negative 1/2. Let's go x plus 2 squared minus 3. And we're going to identify all of this same information about this function. Its vertex is located at negative 2, negative 3. Its axis of symmetry is x equals negative 2. Now, this graph goes down because a is negative. So if we say minimum or maximum, this graph has a maximum value. The domain, again, it's all real numbers. You can put anything you want in for the x. The range is what has limits. Now, the range of this function. All of the y values, that's what we mean by range. All of the y values for this function. All right, so this is going to be a little wider graph. Its vertex is at its highest point, so it has a maximum. We said that its vertex was at negative 2, negative 3. So look at the range now. The range of this function is going to be y. All of the y values in this function, since this function goes down, since the parabola goes down, all of our y values are going to be less than or equal to negative 3. All right, here's your vertex. The graph goes down. Its y values, since the graph goes down, are going to be less than or equal to whatever the y value is at the vertex. You guys good with that? Identifying those 1, 2, 3, 4, 5 pieces of information about a quadratic function. Okay, so we're going to modify the assignment just a little bit today, or I'm going to modify the wording. But for each of the problems that I give you today, I'm going to give you like 5 problems to do. You're going to identify these 5 items, and then you're going to graph the function. Okay? You're going to identify those 5 things, and then you're going to graph the function. So I want to do all of that with you right now and show you what it's going to look like. So we are going to identify the 5 aspects of the quadratic and I'm going to graph it. So if you are given f of x is equal to x minus 1 squared plus 2, we got a vertex that's at 1, 2. Axis of symmetry, that's x equals 1. Minimum or maximum value. Since this a in here is a 1 and it's implied, it doesn't get written, and there's not a negative sign in there, it makes it a positive 1. This graph is going to go up, so it's going to have a minimum value. The domain of this graph or function, all real numbers. The range. The range is going to be y. Since the vertex is at the bottom of the graph, our y values are all going to be greater than or equal to our y value at the vertex, which is 2. The next thing you're going to do is the table of values. So you'll have your x and your f of x. And we said yesterday that the vertex is the first point that goes in your table of values, and we put it in the middle. So we go 1, 2. And then we pick 2 points to the right of the vertex, or 2 points to the right of the x value at the vertex. So I'm going to pick a 2 and a 3. Then I need 2 points to the left of the x value of the vertex. So 0 and -1. Now remember, they're all symmetrical. Since we went the same distance from the vertex, our range values are going to be the same for corresponding inputs. So when we input a 2 into this function, 2 minus 1 is 1, and 1 squared is 1, plus 2 is 3. And when we input a 3 into this function, 3 minus 1 is 2, 2 squared is 4, and 4 plus 2 is 6. So since the right side since the left side is a reflection of the right side, if we go the same distance from the vertex to the left and an input is 0, we're going to get a 3. And now if we go 2 units to the left of the vertex and we input a -1, we're going to get a 6. So your graph would look like this. Your vertex is at 1, 2. So there's your vertex. Then you've got a point that's at 2, 3. And 0, 3. And then a point at 3, 6. and at negative 1/6. So we're going to try to make the bottom of this parabola as U-shaped as possible. And then here we go. So over here is our 5 aspects of the graph. Vertex, axis of symmetry. We've got a minimum value since the vertex is at the bottom. Our domain is all real numbers. Our range is everything greater than or equal to positive 2. All of our y values will be above positive 2. All right? Our table of values shows us where to put the points on the right side of the vertex. And as long as we go the same distance away on the left side of the vertex, everything will be a reflection. Everything is a reflection of this axis of symmetry right here. Here's your axis of symmetry. That's your x equals 1. Anybody have any questions on any of that? I don't see it as being particularly difficult. It's just a matter of understanding the direction and these 5 aspects of these quadratics. All right, so your assignment for today, on a clean sheet of paper, all right, on a clean sheet of paper, name, date, period number in the upper right-hand corner. This is going in the basket when you leave. On page 199, 30 through 34. List the 5 aspects of the quadratic. And graph. List the 5 aspects of the quadratic and graph. And I know I haven't put much homework on focus, but you guys darn sure ain't checking it. So you're going to have to get in the habit of checking focus daily, please. All right, I'm going to start filling in zeros for assignments that aren't finished. Now that's all I got for today. I'll be out for the next 4 school days. Tomorrow, you're going to get a study guide from the sub. I will post the solutions to the study guide on YouTube. Friday, you're taking a quiz in class. Transfer your answers to focus under alerts. Put your number correct on the quiz and put it in the basket before you leave. Monday and Tuesday, you're going to have worksheets that are going to be due at the end of the period. You'll get grades for doing those worksheets or not doing those worksheets. Does everybody understand all those instructions? Okay, Zoom people need to verbally check out at this time. And I'll talk to you guys again on Wednesday.
This is Gabe. I'm good, right?
Yes, sir.
Okay, thank you.
This is Lisbeth. Bye.
Elizabeth. Okay. Add your last name to your profile, Elizabeth.
This is Cameron.
Okay.
Thank you. Cameron, check in on time next time.
Yes, sir.
It's right there. Mm-hmm. Jade or Tiara, you there?